So question 2 on June 2020, paper 1. This question is about the isotopes of chromium. Give the meaning of the term relative atomic mass. Classic question. Just definition question, and they really like to. You should know the definition of relative atomic mass by the amount of times by the including past paper questions. Average mass of one atom of an element on a scale where an atom of carbon 12 is 12. Average mass of one atom of an element on a scale an atom of carbon 12 is 12. Then it says a sample of chromium containing the isotopes 50Cr, 52Cr, 53Cr has a relative atomic mass of 52.1. So let's write that down. 52.1 is equal to something times by something plus something times by something all over 100. We know that the sample contains 86.1% of 52Cr isotope. So that's really nice. So now we can just write that down as this: 52 times by 86.1. However, now we need to work out the remaining. Well, to find the 51, with the 53 one, it's just going to be 53 times by x. And therefore, if this is 53 times by x, it's going to have to be something minus x. 50. Well, if you think about it here, 100 minus 86.1, 13.9. So it's going to be 13.9 minus x. Now we get 5210 equals 52 times by 86.1, 4477.2 plus 50 times by 13, 650, minus 50x plus 53x. 5210 equals 5127.2 plus 3x Have I done this right? 5210 minus 5127.2. No. 52 times by 86.1. Oh, I see what I've gone wrong. It's 50 times by 13.9. 695. Alright. So we'll get 4477.2 plus 695. 5172.2. 5172.2. 3x equals 37.8. X is equal to 12.6. So the abundance of 53Cr is 12.6. It's just X. 12.6. Abundance of 50Cr or 50Cr is going to be 50. 13.9 minus X. So it's going to be 50 bracket 13.9 minus 12.6. Actually, no, it's not. It's going to be 13.9 minus 12.6. Actually, no, we don't need to do that. Yeah, 100 minus 12.6 minus 86.1 would give us 1.3%. So 1.3%, 12.6%. That's part 1 and part 2 done. Part 3, part 4 and part 5. So part 3, in terms of the number of fundamental particles, one similarity and one difference between atoms of 50 Cr and 53 Cr. Like, I think the reason they put this in this A-level paper is because many students are probably going to neglect what's it called, the first chapter, about atoms and particles. So they're going to include a question that is really specific, and you can only do it if you've seen the question before, you know the knowledge. So this one similarity between these two: same number of protons, different number of neutrons. We already know that isotopes, and the definition of isotope, atoms of same element with same number of protons, different number of neutrons. So yeah, that's, if you just realize, yeah, the isotopes, therefore you get these 2 marks. Give 2 reasons why it's necessary to ionize isotopes of chromium. Well, one reason, because ions will interact and be accelerated by an electric field, not kinetic field. And also another reason is that ions create a current when hitting the detector. Ions will interact and be accelerated by an electric field. Ions create current when hitting the detector. 2.5, final part of question 2. The 53 Cr plus ion travels along a flight tube of length 1.25 meters. The ion has a kinetic energy, constant kinetic energy of that. M is mass of ion, V is the speed of ion. Calculate time for it to travel down the flight tube to reach the detector. Okay, so we have got the kinetic energy, the length. To find the time, we need to find the velocity. And in order to find the velocity, we need to find the mass. Okay, now I have a footprint of what to do. So first thing first, we need to find the mass. So the mass of the 53 Cr plus ion, 3 Cr plus ion, is equal to 53, because the mass has to be in kilograms for mass spectrometry, over L. That's the reason they give us Avogadro's constant, over L. 6.022 times by 10 to the power 23. 53 divided by 1000. And we get 8.80 times by 10 to the power minus 26. That's the mass. Now we can find the velocity. We know Ke is equal to a half mv squared. Therefore, 10 by 2, 2ke over m. So velocity squared is equal to 2ke over m. Velocity squared is equal to 2 bracket 1.102 times by 10 to the power minus 13 over 8.80 times by 10 to the power minus 26, which is the mass we just worked out. And then square root the answer. Therefore get velocity. Obviously an exam show velocity squared is equal to that and then square root. But just for this, to show the video, I'm just going to show you guys what velocity is now. 1582575. Now how will this help us? Well, we know velocity is equal to distance over time. We're trying to find time. Therefore time is equal to distance over velocity. Therefore time is equal to distance 1.25 over 1582575. Then you get 7.898 times 51917 times by 10 to the power minus 7, round to 7.90 times by 10 to the power minus 7.